All right. B, let's see, 34. This is really simple, man. So isn't it sine? Number 19. Yeah, that's what I got. Find the area. I say find the area, doesn't it? What are you doing, Mom? Sine 20 minus cosine 70. Find the exact value. Number 2. Number 11. Here, angle. Place the lattice tip on the branch. I say what angle? So you have 6.5 above the ground. And the ladder is this much with the ground. And you have this guy. You're trying to get this angle, right? So it's just going to be sine inverse. Sine inverse of 6.5 divided by 6.7. 75, 24. Yeah, that's what I got. So how many miles is the shape from the base? This is a tan question. Tan. And you have the height. The height. So it's going to be 80 divided by tan of 1. Yeah, I got that one. Okay. right, let's do this. That's pretty simple. All right. There you go. Okay. Hey, Emily, how you doing? Can you hear me?
Hello.
Hey, how's everything?
Good.
How's your Thanksgiving? Good?
Yeah, it was fine.
That's good. Okay, yeah, and it's been a while, I think. How did you do on your exam by chance?
I did okay.
Okay.
The
but
tests are always like,
is that good okay or
it's just like medium. It's like a
okay.
B. It was fine.
Okay, that's good. That's good. That's not bad.
Yeah.
I think if I remember, yeah, you were doing pretty well on the latter treg stuff. So the treg identities, it wasn't that bad. So were you guys like? I know the very first parts of this isn't this treg identities as well. Like you guys were. I'm looking at this as kind of like what you did before. How is this different?
Yeah, it's just like a, yeah.
Okay, we could probably. I'll tell you the truth. Like I don't really like these ones. Like these problems are like one of those ones. Is like if you're good at it, that's good. For me, like I think you guys are pretty much done with the treks. Like you're moving on to the triangles now, right? What else did you guys do this week besides these?
That was basically it. And we did like side angle today.
Oh, you guys did all these guys right here, kind of.
Yeah, we just
Okay. These ones are not that bad. I think the one is when you're trying to find the. Did you guys cover Heron's formula?
No.
Oh, you guys haven't done that yet. Okay.
No.
We'll just cover that. I think we have another one. Your mom, I think, mentioned on the 7th. So let's see if we can take our time with doing these other ones, since you guys didn't cover Herons. Okay. Did you do any of these worksheets yet?
Yeah. Wait, I think it's my notebook.
Okay. Let me see. Because this is the third one, right? You said you wanted to do the third one.
Yeah, and can we try one of the ones on the first? Like
Which one?
When you scrolled up, it was like one of the first things you saw, just so I can like double check and make sure I have it down. Yes, that was.
Yeah, this is the one, right? Okay. Okay. So which one did you want to do?
Oh, sorry, I was getting my notebook. We can do maybe number 3.
Okay, let's see if I can. Okay, I did. Let's see. What would you do with this one? What trig identity? 1050. Let me think. 1050. 1050 minus divided by sine 40. Is this add and sum identity? This is add and, I don't know if this is the one that's familiar. Add and sum identity. Let me think. 10%. I'm thinking sine 50 over cosine 50 minus sine over sine 40. Okay. I don't know if that's the one. And you times it. Do you guys do anything similar to these ones?
We did it like the very, very beginning of the week, so
Okay.
I kind of need a refresher. Not gonna lie.
Same here. Let me look at say tan A plus tan A times B. I'm almost thinking that this won't be in the exam because like you guys already covered these.
But we have like a quiz tomorrow.
Oh, you guys have a quiz on this first one, or is it on the triangle one?
It's on like everything, and it's like the whole over the whole week.
Okay. Let's see if we can do this one. Let me just put in the, if I remember, 10. Let's see. It's supposed to be 0. The answer to this is 0.
Mm-hmm.
I
but
believe.
It's like how
do you get there?
Yeah.
Okay, let me see. They're actually like most of the answers are 0, but let's see. Sine 50 over sine 40 is, so this first part, cosine 2 pi over 9. Let me just do some manipulation. So that's sine 40. Okay. So another way of doing this. And then the other one, tan 50. Oh, so tan 50 is 1 over, it's the same as cotangent 2 pi 9ths. If you do some manipulations. So, and I believe this one is also cotangent, but let's see if cosine cotangent 2 pi over 9. And that's how they would cancel. But how do you get from tan 50 to cotangent 2 pi over 9?
Yeah.
And that's how they equal 0. Let's see how we can do that. So the cosine squared. 2 times pi over 9. What trig identity? What trig identities have you guys covered in the? Did you guys cover all the trig identities? Like in the last 3 weeks?
I'm pretty sure. Let me get the sheet.
Yeah, let me look at that sheet that you guys have. Where is it? Okay, it's right here.
Yeah, we have done all the identities, I'm pretty sure.
Oh, so you guys did. Okay. Let me. Okay, it's right here. Let's look at something that we can apply here. So tan 2, no, that's probably not the one. Tan 2 phi, no. Or tan 2 theta. And then the other one, how can you turn tan into cotangent? That's tan is 1 over 1 over cotangent. Okay, I know that, but what is 50 in terms of the radians? 50. Let's look at that one. 50 over 180. So that's 5 pi over 18. Okay. So how did you get 2 pi over 9? Okay, 2. Yeah, these ones are. Let me see. Yeah, it's 5 pi over 18. I know that.
I knew it was kind of simple when we did it in class. Like we didn't really go into like pies and everything, but I don't remember.
Okay. What identity did you guys apply an identity though, if you can recall?
I don't really think.
Because you have to turn. Like what? I know you have to turn this in terms of this guy, but what I'm thinking is turning it to this guy. But if you guys didn't apply any identity,
freak. Did she send you like the notes that we might have taken?
No, she usually just sends she doesn't send the notes, she just sends the worksheets. Yeah, so actually that's the part that, because like in the 4 things I sent you, most of it was, or the notes that she sent was on the triangles.
Yeah. Okay, then we can try the triangles and we can come back to that.
I can send you what I have for these ones. Yeah, because I was like, you guys already covered some of these, I'm thinking. So I was like, okay, let's just skip it. But yeah, if you want an answer for this one, I'll send it to you after we're done, once I find it.
Okay.
Cool. But the triangles, how do you feel about these guys?
It's not bad actually.
It's not bad, right? Yeah. So, but this is actually one that I don't know if I actually touched on this one, but then there was that one thing where you can apply low cosines and sines. I think you guys are heading towards that. But then you're gonna start out with this, where you just apply like sine and cosine, and then SOHCAHTOA stuff like that, and then the Heron's like formula to find the sides. This very first part right here is pretty simple, right? You just like, they're giving you this guy, and so you just know that this is like AAS, yeah. So yeah, let's not cover these ones because these are pretty simple. But like these ones are the ones that's the core part, is when you're given like any of these, like, two sides, two angles, and then find the other one.
Oh wait, yeah, never mind. We have done that.
You guys already done this one, right?
Okay, yeah. But
And
I mean, we can do one.
yeah, and that's what I'm thinking, like, because these are pretty core. When I cover these, they usually start out like this, and then you cover the lower cosines and lower sines.
Mm-hmm.
But the trick to it, if anything, so they're saying here the C is the right angle, right? And this can be A or B, doesn't matter. Yeah.
Mm-hmm.
And then so when you do 34 degrees, and then usually the opposite is like the lowercase version of it.
Mm-hmm.
And then so you have C here, right? The lowercase c. And then so that's what they're asking you. So what would you apply since this is
So you do sine 34 over 14.7 equals.
Good. Okay. So it's this one, right? 14.7 over sine, yeah? Because this right here is just right? Of SOHCAHTOA.
Or wait, the thing that we used is like sine A over like A, or
You could do
sine
that.
B over B,
Yeah.
equals sine B over B and sine C over
That's like
C.
low of sines or low cosines.
Yeah.
But you'll get the same thing, right?
Mm-hmm.
So when you do, let's see, 14.7 divided by sine 34. And this one, she actually gave you guys the answers, which is interesting. Let's see, 19. Yeah, so it's 26.29, something like that, right? That's what you get. So let's move to, so this one isn't that bad. What about number 20? So you have, let's see, so it's kind of similar. So you have C here, you have A here, and then you have B, and you just fill in what you have, so which is 71 right here, right? And then you have this small c. So you have the hypotenuse, which is what, 36.8. The units doesn't really matter as long as you're consistent. And then so you have b here, right? And this is what you're trying to. So what would you apply?
So you can do sine 90 over 36.8.
Okay, yeah, you could do that one.
Yeah.
Any of these would work. So you said sine 90 equals, or over 36.8 equals b. Or is it the other way? Because let me see if you get the same thing. Because I usually would apply.
You probably have to do for this one, because we've only done like law of sines. You'd have to like find, or wait, couldn't you just minus 90 minus 71?
Yeah, you could do that. Yeah.
But the way 90 plus 71, and then have 180 minus the sum of it.
Yeah, the way I would do it is this. Let's see if you get the same thing. Try doing that and then tell me what you get. So cosine 71 is b over, okay, and then so b is cosine 71, and this is number 20. Yeah, what did you get?
You tell me what you got first.
11.981.
Okay, yeah.
Okay, so the way you did it, you could do it that way, but it might be an extra step. You could technically apply, like I said, you could apply SOHCAHTOA, which is like always works every time. Yeah, and you know what I mean, though, right?
Yeah, where you can just plug it. Yeah.
Yeah, because if you don't have to always default to sine. I mean, yeah, it makes sense because she gives you guys the formula, but the formula is just a formula if you know how to use it. I would just stick to the basics. Okay. Hey, yeah, these are pretty fun. These are like the main thing that pops out. Like if you're gonna go to like probably like advanced math or engineering, these are the ones that you need to know. Because these are like all these trig identity stuff. It's just used for like simplification. But if you're gonna be using physics, like like finding forces and stuff, these are the ones that you will need. And okay, let's try more of them. So let's see. You always have to be drawing something which is by default. So C, and then you have A here, and then you have B, whatever. And this one is 29.6. And then you have A right here, and then B. Well, which one would you apply in this case? You have two legs, right? And an angle. You would apply this one.
Tan?
Yeah, so when you do tan, because you have A and B, which are two legs, and then so you do tan 29.6, and the TOA, right, is the opposite is A, which you know. Let's fill it in. A is 4651, and then you don't know B, and you just do some algebra, 4651 over tan 29.6. And that's how I would do it. It's really just applying that instead of like memorizing a formula. So let's see what they got. Yeah, so they got the same thing. They got 8187.24. What would you do? There's like so many different ways of doing this, aside. But my way of doing it is just doing SOHCAHTOA and then just doing some algebra.
Yeah, that's actually like kind of easy.
What formula is she? Did she give you guys? Which one is that one?
Sine A over A equals sine B over B equals sine C over C.
Oh yeah, so I think this is the law of sines, isn't it?
Yeah, I think so. Probably.
Law of sines, yeah. Yeah, this is the law of sines. But the thing is, you have to do a sine, right? You have to always manipulate what you have to get a sine. You could either do it this way or just remember SOHCAHTOA. I would do this, which is more versatile, right? Yeah. Okay. Let's do 22. Let's see if we can apply the SOHCAHTOA. So let's see. So C, A, B, B, A, C. So you have this is 35. This is 27. And then you need to get B. You need to get B. So this guy, what would you apply in this case? This is opposite, right? This guy's opposite, yeah.
So you can do, wait, is that the hypotenuse? Yeah, okay.
Yeah. You can either or you can do ka.
Yeah.
I mean, either way, I would stick to the simplest where you don't have to do any more manipulation or like any other additional step. So I would just do so, right? But you have to do a sine inverse. Sometimes you have to do that, but you already know how to do that anyways. 27 over 35, right?
Yes.
And then you just do sine inverse or arc sine, and then what? Let's see what we got. 27 over 35 is 50 point. Yeah, they got the same thing. 50.5 degrees. Using your teacher's way. I guess you could. Can you do it using that?
Yeah.
Yeah. What would you do? Let's see if we can do it that way. So you do sine B, right? So it's sine B. So over 27. And then like sine 90, I guess sine C over 35.
And then you cross multiply, so you get like 35 sine B.
I don't like. There's always that extra sign. Okay, yeah, you could do it that way. Yeah, it should be the same.
Yeah, okay. And then you just have to like divide. Yeah.
All right, let's look at this last one before we do the problems, the word problems. So let's see. And this is C, A, B, and then you're given A 4398, B 641.2. And okay, so you need to find A. Which one would you apply? You're given two legs, two sides. TOA, right?
Yeah.
This is kind of similar to the other guy. So tan of A, another inverse, 439.8 divided by 641.2. A tan inverse 39.8 1.2. Let's see, 439.8 divided by 641.2. What did they get? 34.4. Yep, I got that one. Cool. How would you do this with the sine, the law of sines?
You would do sine 90 over x. Oh wait, so we're finding a. Okay, then you can do. No.
Okay.
No.
Not
So
that
you can
one.
do.
Okay.
Wait, is there? Okay, there's one angle, but I mean, it would be really hard to do.
Yeah. Okay.
Can
you
that for that because there's no
I
angle.
think you have to do log cosines. If you guys did log cosine, I think you could do it. I don't know if you can do log sines. Can you? Because you're not given any of the other angles, right?
Yeah, you're not giving another angle, so kind of.
There's like no way. Yeah. So I think you either do it this way or you have to do log cosines. Okay. Well, you guys didn't learn log cosines yet, right?
No.
Okay. Yeah. So we'll cover that once you guys learn it. So this one, if it was me, I would probably give you guys like more problems like this, but this isn't really that bad. If you take a look at this, you just have to like, go over what these mean, right?
Yeah.
So this is like what the cat is trapped in the tree above the ground, so that would be straight up, and then you have this guy, right? 6.7, and it's asking, what is it really asking? It's asking for this guy right here.
Yeah.
It's asking for this guy. So which one would you apply? This is obviously the right angle. Yeah.
You do opposite over. It's opposite in the hypotenuse, right?
Yeah. So okay. So it's just let's say sine. Let's just go over a step. So 6.5 over 6.7, and then sine inverse. So they're really simple, but it's a basic like knowledge that you need to hone because yeah, you'll definitely see this again. So the answer is 76. They rounded. Okay. 76 degrees. All right. That's not that bad. Okay. Why don't you do this one? It's not, these aren't that bad, but they're pretty good. Why don't you do this one? This one.
So,
yeah.
So it's depression, so it would like go down, right?
Okay. So you have, so this first guy, yeah. So this guy right here is an angle, and then you have this 80 feet, right? Is this the vertical one? It looks like it sounds like it's the vertical one. In a lighthouse, 80 feet above. So it's probably this guy, right?
Mm-hmm.
And then the question is asking how far the ship is from the base of the lighthouse. So
it's asking for like the X at the bottom.
Pretty much, yeah. So this is the ship right here, right? And then this guy is 1.1 degree, right?
Mm-hmm.
And it's just asking for this guy. Exactly.
Yeah. So
which one would you apply?
I'm not sure because there's a angle.
This guy, right? Yeah, no. Every time there's
an
angle, yeah, you can always do toa, yeah, toa. That's why, like, I don't want to do the low sines because you're always thinking like, what's the step I have to make to make it into a sine? But if there's an angle here, and you have two legs, leg and hypotenuse, always apply toa.
Oh, okay.
Yeah, right. Like,
yeah.
If you just remember like toa, it's really the only thing you need. Instead of like thinking about. Yeah. Okay.
So you do 80 over x, right?
Yeah, 80 over x, and then tan.
And 1.1.
Yeah. And let's see what we got. This is asking you to convert it. Let's say. So let's say 80 over tan 1.1. 80 over tan 1.1. So you got something in feet, right? You got something in feet, and then you just convert it to miles. So 4,167 5 to 80. So 0.79 miles, which isn't that bad, right? It's just the math part is this guy.
Yeah.
Okay. Let's actually look at, let's see this one. So those are pretty basic. Let's see. Determine the number of possible triangles. What is this? Yeah.
Okay, we worked on this today.
You guys worked on this today?
Not like this worksheet, but like we worked on these type of problems.
Something similar, yeah. Okay. How did you guys do it? I mean, like it looks like it's similar to what we were doing.
Yeah, because it's like, isn't this?
Let me just draw it out again. But the thing is this it doesn't tell you which one is the C, right? Let me see. Given the following information about determine the number of possible triangles.
Oh wait, never mind. We worked on this like yesterday, I think.
Okay, so there's still a right triangle then, right? Let me see. 180 minus 52 minus 31.
No, it doesn't say if it's the right triangle.
It's not actually. So yeah, I guess you just have to create. You just have to create the angles or whatever triangle. So let's see. B, C, 52. But the same rules apply, right? Like it's pretty much and then this one's 97. And then you have A as 8. And then you have you have to get this guy. So so you can't apply the SOHCAHTOA. You can only apply the right angle.
Yeah.
So then in this case you have to apply law of sines then, right? Yeah, so sine of 52 divided by, that's the caveat. Yeah, you can only apply the SOHCAHTOA. It's a shortcut. I mean, most things there is a right angle, most things. So let's see, A, so that's 8. And then what are you trying to find? The B one, so just put B here, sine of 31, right?
So you can only use SOHCAHTOA when there's a right triangle?
Yeah, because there's that's the hypotenuse part. The hypotenuse part in the TOA, whatever. But that is the shortcut, yeah. So let's see, sine 31 divided by sine 52 divided by 8. What did they get? Okay, I got the same thing. So yeah, it's 5.23. So yeah, this one isn't bad. I mean, we have to default to the law of sines. Well, that's fine. But are you comfortable with this one? Like it's pretty much you've been doing this, right? This is what you guys do. So let's just do 27 or a few more of these. So let's see. And you always draw a triangle, it's always the case. 28. B, C, 117. 180 minus 117 minus 28. 35. Then is B equals 6. And then C is the one that you need to find. So sine of 35 over 6 equals sine of 117 over C. C equals sine 117 sine 35 over 6. Pretty straightforward though, right? Yeah, it's really, and now I think it gets easier. The only part that's always tough is the identities. Those are the ones that are not as straightforward. Let me see that. Yeah. but I think like it's just gonna be because like this, your class is like this is like a whole year, right? Okay. I don't even know what's after the triangle. So I guess after the triangles, you guys. Oh yeah, this is a precalculus class. This is a precalculus class. So you're probably gonna cover like limits or something like that. Maybe calculus stuff beforehand. Okay. All right. We don't need to cover all of them, right? We already know how to do these. Yeah, they're not that bad. Let's just do this one, finding the area of a triangle. So let's see. So there's two ways of doing this. You could do 1/2 base times height, or you can do.
I don't think we've done this.
Oh, you guys haven't done this yet?
No.
Okay, you might as well cover it because we still have time. But well, if you're gonna see it, this is one way of doing it. The other way of doing it is Heron's formula. It's in the if you want to look into it before you guys cover it, it's in the first worksheet that I sent you.
Okay.
Which are pretty much her notes, teacher's notes.
Did she send you any that are like angle side side?
Angle side side.
Yeah.
Like the formula or how to do it?
Like, cause you have to find out like how many triangles are in for angle side side. Like how many triangles can be made.
Okay. Oh, you mean for these ones, like this guy right here? Because
Yeah.
it's determined number positive. So let's say angle. Let me see if there's an angle side one. Angle, like this guy, angle side.
Mm-hmm.
Okay, we actually didn't cover that one. Okay, because so let's see. Oh, I see what you're saying. So
yeah, determine number of possible triangles.
So before we cover that, let's cover this one. So let's see, 34. And then you have this as like A equals 4, and then B equals 3. Okay. How did you guys, or like, what did you guys do to do that? Like to figure out how many triangles?
So we have to find out the height of it. And then
The height of it? Okay.
So like the angle is acute. So if it's acute, like
yeah.
If the other leg is longer than the height, then there's gonna be one.
Yeah, this is like that one. There's like
Aha!
Yeah, it's been a while since I've done this. So continue saying it.
Yeah, if it's longer, then it's gonna be 1. But if it's like longer than the height and shorter than the other side, then it's gonna be 2. And yeah, and if it's shorter than the height, then it's gonna be 0.
What do you mean 1 or 2? Like not the number of triangles?
Yeah, that it can make.
Ah, okay. Man, let's see what the answer is first. And let's see, kind of confirm what you said. Number 28. So there's one triangle, right? One triangle. And then so it's one triangle if it's. But how do you get that?
It can either be the same length as the height or more.
So this height, right? Or
yeah, you have to find it.
Let's see if we can do that. So we have 34. Yeah, you could do that one. And then this guy right here is just done. Let's say 180 minus 90 minus 34, 56. And then since you already have, so you have, so this one, just make it H. And then since there's a triangle, you can pretty much apply what you know. So let's see what you have. So you have A and then 34. Okay, I will just apply sine. And 34 equals H over 4. And then so H equals 4 sine 34. Okay, so after that, what is it?
Okay, so because I think it's find C. So I have to find like C too.
Okay, you have to find C. And let's see. So
it'll be on that side.
So you have C 34 sine using the law of sines.
I think you can do that.
Let's see. So sine 34 over C, which is what you're trying to find, and then
you can use.
You don't have the other guy.
Oh yeah.
Yeah.
Pain.
So what do? So it does get difficult.
I guess you have to find the angle of another one, I guess. But like,
Let's see. How would you find? How would you find it when there's like many options for it? You know what I mean? Yeah. Like how would you find it? You said so. Oh, so did she cover something similar to that? To this?
Yeah, today.
Cool. Let's see. So, how did you find C? Because they found C. Oh, let me think. Actually, maybe you did. You guys did cover low cosines to find the angle. So you have A, B. So you have A and B. That's good. But you don't have C. Oh, I think I found it. Yeah, you do have to do the low cosines. Let's actually do the low cosines. So cosine
There's a formula.
What formula? Because I think you do have to do. Did you hear what I said? I said you have to do the law of cosines.
Yeah, but we haven't learned that. But she gave us a formula where it's like height equals adjacent sine of 40.
Height equals what? Adjacent sine.
Like that's literally what it's. It's
adjacent. What the heck is adjacent sine?
I don't know. Adjacent sine 40.
Adjacent sine. Is it arc sine? Is it
it's
arc sine?
ADG and then
ADG.
in parentheses sine 40.
That's super weird. What the hell is that? Don't use that. Honestly, I don't even like. What would you do with that one? I'm just gonna write what I have first, but like let's what would you do with that one? Like the one that you said.
I don't remember.
Because this formula here. Let's just try this, and maybe you guys will cover it. No, I'm pretty sure you guys will cover it. Low cosines, and try to apply it in this case and see if you find the answer. So you know how you have this big C, right?
Yeah.
And then you have this A, right? Small a, small b, small a, small b, right? And you only need to find small c. So you could figure this out, right?
Oh, okay.
Yeah, but try to, if you wanted to Google it, just Google law of cosines, because it should give you, in this case, yeah, because you apply law of sines if you're given two angles, and then if you're only given one angle and a bunch of like sides, you apply law of cosines. Because this can, this is one way of writing it, but let's actually just do it so that you can figure it out. So let's see, cosine of 34 equals 4 squared plus 3 squared. And so c squared is right here. And then you do 2 times 4 times 3. This is more straightforward. I don't know why. Maybe that's kind of like that adjunct thing that she's talking about. It sounds like advanced math. I've seen something like that before, but I'm like, why are you applying it here? 4 squared 16 plus 9, 8 times, so that's 24 c squared. So cosine, let's not do any math yet, or minus 16 minus 9 equals minus minus 24 c squared. Hopefully this is not negative. Cosine 34 minus 16 minus 9 divided by. Oh, good. What was the answer for this? Oh, shit. Where was the answer? Yeah, 28. 2.26. Let's see. 24 minus 24. 2, 4, 8, 24. Okay. Oh wait, I made this. It's a 16 plus 9 minus 25. That's still the same thing. Ooh, okay. C is 1.0, right? 2 times. Okay, that's cosine. Okay. It's a little weird. Why is it? b squared minus 2. Number 28. I got c equals 1, but I don't know if they got the same thing. For some reason, this thing doesn't give you the right answer. I don't know if that's the same thing.
Maybe you have to do the adjacent thingy, but I don't know how.
Tell me that again. Tell me the formula.
It's high equals ADJ, yeah.
ADJ of sine of what?
40.
Sine of 40? Like, why is it so specific? What in the ADJ of sine of 40? I'm always wondering if that seems like it's a fluke that the answer isn't the same.
Maybe you're right and they're wrong.
I don't know who wrote this. Sorry. Did she write this?
Sometimes she does, and she accidentally makes mistakes.
Okay, let's actually do the other one because it's kind of similar. So cosine of 13 equals 12 squared plus 5 squared minus c squared. Oh, but this one's asking for a though. So you don't actually apply this one. So let me see, find a. Also, you would find a. You would do log cosines and log sines. Let's actually do that one because you need to find a first. The sine of c, sine of b. Yeah, so you do a squared plus 5 squared minus 12 squared to a times 5. Okay, and then so 13, so a squared 5 squared minus 12 squared is minus 1. Hold up. Minus 25, 12 squared, 2 times 5. So that's minus 440a. And it's a cosine 13 plus 25 equals a squared minus 14a. And then so, okay, so this one you could actually apply 14a minus cosine 13 plus 25. So A, B, and C. This is 1. This is minus 1440. And then let's see, cosine 13 plus 25. That's minus 25.975. So let's look at the quadratic formula. So that's 1 negative 440 minus cosine 13 plus 25, or minus 25. And then so A can be negative, so it has to be this guy. So let's see. So you do sine of 13 over 12, and then sine of A over 1440.02. And then so sine of A in 0.02 sine 13 over 12. So what is A? Times sine 13 over 2, or 12. Let me see, plus 20, wait, hold up. Oh, that's fine. Okay, so this is plus 25. What did they get in this one? $161.6. I say 161.6.
How?
They got 161.6. That's actually, it seems like it makes sense, but it's just a large one. But I'm skeptical about this 1440 right here. Let's look at this again. So a squared minus b squared minus c squared 2 times a times b. So we don't have a. Let me look at the formula again. So let me think. So you have really cosine of a. The other formula for this, if you don't use that, is cosine of a, which is the same as another version of these guys. B squared plus c squared minus a squared 2bc. And you need to look for this guy. And then you don't have this guy though. I don't think you need to. Can you you guys did the adjunct way, right? Did you guys work that out in class?
We did. It was like we did it on a worksheet that we turned in. So I don't.
Oh, you guys turned it in. You don't have notes for it?
I can try and see if someone can send me it, and I can send you it.
Okay.
After.
I want to see how, because there must be another way. I've never seen it that way, which is weird. Adjunct. But let me see if I can find another way, and then maybe we can meet on Sunday. Is it Sunday? I forget if it's Sunday. The 7th. I think it's on Monday. I think the next one is on Monday. Can you meet on Monday instead?
Yeah, that's fine.
Okay. Yeah. So if you send me that one, I'll look into this angle side, and also the treg stuff.
Okay.
But in terms of your quiz, you have it tomorrow, right? Just practice some of these. Actually, if I have time right now, like after this, I'll send you the how you figure out 28 to like 33 or 28 and 29.
Yeah.
Using the way your teacher did it. And I think that might be helpful for you. Cool. All right then.
Bye.
See ya.